All right, okay. So now let's talk about another sequence or progression, whatever you want to call it. You can call it a sequence, you can call it a progression. It's usually basically called geometric progression. In some books, you'll find GM, and yeah, that depends, okay? So let's talk
Okay.
about this one. All right, okay. So now we need to understand what exactly happens in a geometric progression. Let me write down an example and then things would make sense. So if I say, if it's 1, 2, 4, 8, 16, and so on, what would you understand by the sequence? What do you think? What's happening in the sequence? Every term is being multiplied by 2 to get the next term, okay? Every term is being multiplied by 2 to get the next term. For example, if you look at the first term, it's 1. In order to get the next one, we will do 1 multiplied by 2. Similarly, if we look at the third term, we are getting 4 by doing second term multiplied by 2, and so on. Every term is being multiplied by 2, and then you're getting the next term. So this is something that you need to understand. For the arithmetic progression or arithmetic sequence, something was being added or subtracted. Here something would be multiplied or divided, and that something would be fixed for every term of the sequence. Let's talk about another one. Now let's say we have 27, 9, 3, 1, 1 by 3, and so on. What do you notice? Is it a number that's changing? Are you adding or subtracting a number? No, that's certainly not the case.
Nope.
You are dividing every
Yes.
term by 3 to get the next term. So it's 27. We are doing 27 divided by 3 to get 9. Then 9 divided by 3 to get 3. Then 3 divided by 3 to get 1. And then 1 divided by 3 to get 1 by 3. So what is the idea? The idea is, in geometric progression, in order to get the next term, either you would be multiplying the previous term with a number, or you would be dividing the previous term with the number, okay? This is basically the idea, but we usually think about it this way, that we, yeah, you can think about it this directly like this, okay? I'll talk about it in a while, okay? So any other example required to understand what geometric progression is? Let's talk about one last example. Let's say it is 1 by 2. Then the next one is 1. No, let's say 1 by 4 is a better idea. 1 by 4. Then the next one is 4. Then it is 16. Then it is 64. And so on, okay? So you can clearly see that obviously the difference in all the terms, or the common difference, is not there. This is not arithmetic. So far you only know arithmetic, and now you know geometric, some part of it. So you can see, in order to get the next term, you are multiplying every term by 4. Every term is being multiplied by 4. So this is fixed. This is fixed. Just like common difference used to be fixed, this is fixed, okay? So this is the difference in arithmetic and geometric progression. Okay. If I quickly go back to what we discussed in the beginning of arithmetic, here it is. Plus 2, plus 2, plus 2 was fixed. Then plus 1, plus 1, plus 1 was fixed. Then plus 3, plus 3, plus 3 was fixed. And here plus minus was fixed. And whatever we have discussed so far in these sequences, multiplied by 2, divided by 3, and multiplied by 4 is fixed. This means for geometric progression, we have other way around, right? We have
Yes.
a common ratio.
Yeah.
In arithmetic progressions, we used to have common difference, and here we have a common ratio. So we'll talk about that later on. For now, let me talk about another one. Okay. So with reference to this first this example, let's talk about everything now. Okay. Now in geometric progression, we have a few terms again. We have A. A is the first term, that's same. And then we have R. R is basically the common ratio. And I'll tell you how to find out the common ratio, okay? So let's talk about a sequence for this. Let's say we have 2, we have 6, we have 18, we have 54, and so on. Let's talk about the sequence. What is A? A is the first term, that's same. This was the first term for arithmetic progression as well. A is always the first term in sequences and series, okay? So this A is basically the first term of the sequence. And how do I find R? In order to find R, what you can do is pick up the second term, 6, and divide it by the previous term, that is 2. This would give you 3. Let's say for some scenario, if you were not given with the first 2 terms and you had some middle 2 terms, okay, you just need 2 consecutive terms. Just pick up the second term and divide it by the previous term. And the common ratio is going to be same. Let me explain this again through another example, and then you would understand the idea. For example, let's say if I talk about 1, 3, 9, 18, and stuff like that, okay? So for this one, I'm interested in finding out the common ratio. I can pick up any 2 numbers of my choice, but 2 consecutive numbers. Let's say I'm picking up these 2. In order to find the common ratio, I'll pick up the second one because from my choice, this is second and this one is first. 9 divided by the previous number is going to give me 3. So 3 is going to be my common ratio. Okay. Similarly, if I would have chosen 18 and 9,
Yeah.
in that case, it would have been 18. One second. This is obviously 27 because I went wrong here. So it would be 27 divided by 9, and that would again give you 3. 27 divided by 9, and this would again give you 3. Because what was happening? I multiplied 3, again I multiplied 3, and again I multiplied 3. Okay, so this number is basically your common ratio. And if it's divided by 3, then in that case, the common ratio would have been a fraction. Let's talk about another example. This was the first one. This is the second one. We are just seeing how to find the common ratios. Oh, it's hard. Okay, and the third one, let's talk about it now. So imagine that 16, 8, 4, 2, 1, 1 by 2, and so on. Okay, again the idea is that how do we find the common ratio? It's R equals, pick up any 2 numbers of your choice. Let's say I pick up these 2 numbers. I need to go with the second one. It's 2 divided by the previous one, that's 4. So it would be 1 by 2. So you certainly can have fractional ratios as well. That is also mathematically correct. You can have proper numbers, you can have proper fractions. Okay, if I talk about these again, 1 by 2 divided by 1 would again give you 1 by 2, right? 8 divided by 16 would again give you 1 by 2. So in order to find the common ratio, it could be a proper integer, it could be a fraction. Just know that you need to pick up any two consecutive numbers of your choice from the sequence and then just do the second number divide by the previous number. Okay.
Okay. Yes.
Any difficulties?
No.
Okay. All right. So considering this, if I talk about a scenario, a random scenario, it's important. We know that the first term is A. A is the first term. Every time it's A. And R is the common ratio. So imagine the first term is A. What would be the second term? It would be A multiplied by R, because R is the common ratio. In order to get the next term, I will do the first number multiplied by R and I would get this one, right?
Yes.
Okay. In order to get the third number, what do? Again, I need to multiply the second one with R. So what would I get when I will do AR multiplied by R? I would get AR squared. Similarly, for the third one, it would be AR cubed. So this was the first term. This is the second term. This is the third term. This is the fourth term. So what do you think? What would we have in the nth term? A is fixed. A is coming in every term. R is coming in every term. The power is different. What is the link in the number of term and in the power? It would be 1 less than the number of term, right? So it would be AR n minus 1. This implies that the nth term formula for geometric progression is going to be AR n minus 1. This is what I wanted to talk about over here. Okay, let me explain this again, and then you would get a better understanding. Are you able to see my screen?
Yeah.
Okay.
No.
No?
No.
1 second. Let me just share it
Oh,
again.
I just said before I couldn't hear you, but I don't think you heard.
Just give me 1 second. Can you hear me now? Yes, can you hear me, Madiha?
Yes, I can hear you now.
Okay, all right. So basically, we were talking about a scenario. A is the first term and R is the common ratio, okay? So if A is the first term, I can write down A over here, certainly. And I know that if R is the common ratio, I would get the next term by multiplying R with the first one. So what would be A multiplied by R? It would be AR, right?
Yes. Yes.
And if I am interested in finding out the third term, I will do R multiplied by the second term, and that would give me AR squared, okay? And so on and so forth. I got AR cubed, and then I wanted to notice something. I wanted to find out the nth term. This was the first term, then we had the second term, third term, fourth term. But what was happening? Every time the power of R was 1 less than the term number. So when we were at the fourth term, the power of R was 3. When we were at the third term, the power of R was 2. Similarly, when we will talk about the nth term, the power of R is going to be 1 less than that. So it would be R power n minus 1. Okay. This is how we can understand the derivation of the nth term formula. If you remember, we studied an nth term formula for arithmetic progression as well. And here it was, okay? This was the nth term formula for arithmetic progression. Here, this one. Similarly, we have an nth term formula for geometric progression as well. Okay, here is the geometric progression, and I have written the formula after deriving it. Even if you did not understand the derivation, the formula should be clear. Any confusion so far? Anything that you were not able to understand?
And no, I get it.
Okay, all right. Now we are in the position to talk about questions. Example number one. Example number one says, the fifth term
Oh, your voice has gone again.
sorry, yes, now it's clear. The fifth term of a geometric progression is 1, and the common ratio is 1/2. Find the eighth term and an expression for the nth term. Okay, all right. So this is the question. So you have been told that it is a geometric progression. If examiner would not mention this, in that case, he would give you a few terms just so you are able to recognize which sequence of progression is that. So you know, let's talk about the solution. You have been told that the fifth term is 1 and the common ratio is 1/2. Find the eighth term and an expression for the nth term. So what do we know? We know nth term for geometric progression is a r n minus 1. So the nth term is 1 and n is 5. So it is 1 equals a multiplied by the common ratio, that is 1/2, and n is 5, so it would be 5 minus 1, that is 4. And now I can make a the subject, so this would give me 1 equals a divided by 16, and I am going to get a equals 16 as the first term. Okay, so a equals 16, the value of a is 16, and I got this using the nth term formula. So I have something now, and I am in the position to find out the eighth term now. Okay, all right. For the eighth term, it is again a r 8 minus 1, a is 16,
Yes.
r is 1/2, and the power would be
1.
7 now.
Yes. 7.
And after simplifying, I would get 1/8. So this is going to be the answer for the first part, where we were asked to find the eighth term and an expression for the nth term. So nth term is equal to 16 into 1/2 power n minus 1. For nth term, you're just supposed to write down n instead of any value, and this is going to answer the second part of the question. Is it okay?
Yes.
Any confusions?
No.
Okay. All right. Let's talk about the next question then. And these questions are exactly like the past paper questions. Like the difficulty level is absolutely same.
Yeah.
Example number 2 for this one. Okay, now I'll just write it. I'll read it and then I'll write down the data. The second and the fifth terms in a geometric progression are 12 and 40.5. So again, it is a geometric progression, and we have been told that the second term is equal to 12 and the fifth term is equal to 40.5. Find the first term and the common ratio. Okay, all right. So you need to find out A and you need to find out the common ratio. So the question is basically the second and the fifth terms in a geometric progression are 12 and 40.5 respectively. Find the first term and the common ratio. Hence, write down an expression for the nth term.
Yeah.
Okay. This is basically the question. All right. Okay. So I'll just help you with the interpretation of data and then I would want you to find A and R. If we talk about the solution, I've been told that the second term is 12. I know that the second, let me write it down that way, or let's say this way. The second term in general is equal to AR to the power, it's n minus 1, so it would be 2 minus 1. Second term is 12 equals AR. This is going to be the first equation. I'll make the second equation using the second piece of information. Now I know that the fifth term is basically equal to 40.5. So fifth term in general is equal to AR n minus 1. So 5 minus 1. So it's 40.5. So it would be AR power 4. And this is going to be the second equation. Okay. Now you have your two simultaneous equations which you need to solve and find out the values of A and R. So can you give it a try?
Okay. Yes.
Okay, so I'll wait for 2 minutes. Try finding out the values of A and R. I'm here. I'm just muting myself.
Okay.
Yes. Are you done?